Recording started.
This recording is from Thursday, October 13th, Earth Science 112, and today we are going to be completing our 3.08 Rock and Mineral Lab. What I want you to do right now, if you have not done so already, Keelan, it looks like Keelan and Alicia, you're the only two we're waiting for. I need you to go into Doc Sharing, and I need you to open up your 3.08 lab report and save it in your Earth Science folder. Once you have that done, go ahead and post a green check. So Keelan, go ahead and do that now. We're still waiting on your green check. That's what I figured, Alicia. No worries. I'm going to close this door. I should be back in my house by next week, so you won't hear the first grade math going on in the background. Keelan, green check. Are you in here, Keelan? If so, give me a smiley face. We're waiting for your green check. As a reminder, this is for those of you watching the recording. If you're not sure where to find this, it's in Doc Sharing. 1 second for me to show you where to find this. So you're going to go into the course. If you want to do the lab yourself at your house, you do need your rock kit. If you're going to just follow along, you do not need your rock kit. And I'm going to go over your options. You'll be able to complete the lab both ways. Okay, sorry, it's timing me out of the course. So you're going to go into your course. It looks a little bit different to get into yours than mine. You go through your student homepage. What button do you have to click? What button do you have to click? I have a lot of new students. You may be watching the recording. Veterans, can you tell them what button they have to click in order to get into the course? What color is it? I know you guys know this because you all do this every day. It's the bluish purple one that says Access Course. You have to click the Access, yes, Lucy and Alicia, the Access Course button. When you're in the course, remember, and this is just a reiteration for you folks that are here because you guys all know this, your lessons are in the calendar. Tomorrow we are already done Unit 3. We did a whirlwind tour of it. We're going to be moving pretty quickly through the remaining units because we actually only have 3 weeks left to finish Unit 6 and 7. Well, 4, 5, 6, and 7. So we're going to be moving at a pretty quick pace. And what will happen is on November, I think, 7th is the final review for the first half of Earth Science. Lucy, I know. It's the block scheduling, and I'm hoping that next year we'll be back on regular scheduling because this has been crazy. What we're doing today, we did at the end of November last year. Anyway, you'll do the study guide tomorrow morning at 9 a.m. I will be in here for help with the study guide. If you guys want to work on the study guide with a buddy, you can come in here and I can put you in a breakout room. And also for those of you that are watching the recording that may not be doing as well in this course, you'll be getting a K-mail inviting you to a session tomorrow at 9 o'clock to get your grade back on track before the end of this first half of Earth Science. All right, today we're doing the lab. Going back to what I came into here for, Doc Sharing. You're going to go into Doc Sharing. You're going to open up lab reports because this is the lab reports, and you'll see 2 documents. Directions. Ms. Hoffman-Long took some time last year, that's myself, to go through and rewrite these so they're easy to follow. Here are the step-by-step directions that you should be able to follow in order to do the lab, even if you don't watch the recording. And you're going to need the lab report. And that's also in Doc Sharing. You'll go into Doc Sharing, just like everybody in here did. Keelan, still waiting on that green check. Danny, I need a green check. You should have your lab report open and we're ready to go. And this is what the lab report looks like. Remember, you can make this larger by zooming on your computer. Okay? Everybody's got the lab report up. We're going to go ahead and get started. You're going to submit this lab report by the end of the day today, Thursday, October 13th, into the 3.08 Dropbox. You don't need a microscope for this, but you do need a hand lens. By the end of the day today. My sister burnt her toast and it is black and smelling up the whole kitchen. Okay, let's go back to the PowerPoint. So we know where to find the lab report. We know what we're doing today. We know where to put the lab report when we're done. We don't need to go over eliminate rules because you folks are awesome. Alright, Danny, make sure you get that lab report open and put up a green check. So today, you're actually going to be performing tests for hardness, color, streak, and special properties on mineral, and this should also say rock samples. You're going to use the results of these tests to identify several different mineral samples. Before we get started, and before I turn on my webcam and you get to see my lovely, I only got 4 hours of sleep and only had time to slap on some mascara after I washed my face, we're going to go over a quick review. I'm going to give you your whiteboard tools. Using your whiteboard tools, we talked about this a little bit last chapter or unit, and you should have read and taken notes on this yourself last week. What type of rock is formed from a volcano? Go ahead and use your pointer. Is it sedimentary, metamorphic, or igneous? What type of rock is formed from a volcano? And I should see more than just one light bulb on that whiteboard. Yes, go ahead. Can you guys circle the word igneous for me? Can you circle the word igneous for me? So to do that, you're going to click on your circle tool. There we go. Perfect. And somebody used purple. Okay, igneous. Whenever you see volcano, you should think igneous rock. Remember, they can be formed from magma or from lava. Looking at this picture, Doug, go ahead and open up your 3.08 lab report and then follow along. What type of rock? How do we know? So let's take a quick look at this picture. We have land, we have weathering and erosion going on. That material is washed into the sea from land. We have living things that croak, that die and go and start to break down. We have remains of these living things like plankton and tiny forms of sea life. And over many years, they start to form layers of sediment. They start to form layers of sediment. Over here, I'm going to put a box up. I want you to use your whiteboard tools and click on the blue letter A. Type in this box what type of rock you think this might be. Metamorphic, igneous, or sedimentary? Which one? And you don't have to type the whole word out. You can abbreviate. Which one? There's only one correct one here, and there's two really major pieces, important pieces of information that we look at in this picture that should give you a clue. Yes, sedimentary. And I went ahead and underlined when I was reading because this is what I like to do when I read. When I see something that supports a key concept or an objective, I like to make a note of it or underline it. Layers. When you think of sedimentary, you should think of layers. And these layers can have both organic and inorganic. Okay? When we're talking about this, we're talking about organic. And when we're talking about material like rock and sand, we're talking about inorganic. So our sedimentary rocks are composed of both organic and inorganic matter. And right here we have the Earth's surface. What part of the Earth, what do we call the Earth's surface? There's two words that we've learned in the chat box. What are two words we learned for the Earth's surface? You can share one or you can share two. There's two words we've learned for the Earth's surface. The crust, very good. And then there's a bigger, more scientific one. The mantle is underneath the crust, so that's not part of the Earth's surface. That's down here. That's our mantle. Lithosphere, very good. And that's the word we want to start using when we're referring to our Earth's surface. Our big scientific word, lithosphere. Okay? Over many years, we see pressure from the weight of overlying rocks pushing down and forming rocks. It can push down on sedimentary rocks, it can push down on igneous rocks, it can push down on metamorphic rocks and form new rocks. What type of rock is this? Key word here is pressure. And here, what do we have down here? What do we have down here? Molten rock. These little wavy lines, what are they representing? Molten rock. What temperature is molten rock? Heat, right. So we see heat and pressure. We see heat and pressure over many, many, many years. What type of rocks are formed from the result of heat and pressure? Pressure. Bearing down on me. I always get that sound stuck in my head when I teach this. There's only one left that we haven't talked about. Is it a sedimentary, a metamorphic, or an igneous? Note that we're doing a quick review of last week before we start the lab. So on the whiteboard, go ahead and type which one you think it is. And if you said metamorphic, you are correct. This is metamorphic. Keep in mind that metamorphic, thank you very much for whoever's typing, metamorphic rocks, these can be formed, we're going to get rid of that really big print. Our metamorphic rocks can be formed from any type of rock. Metamorphic rocks can even form from metamorphic rocks, which seems kind of silly, but remember metamorphic, it's changed rocks formed from heat and pressure. So igneous, sedimentary, or metamorphic rocks can change from one form to another as a result of heat and pressure and make a new metamorphic rock. When you think of the word metamorphosis, what do you usually think of? If you think back to elementary school, and if you guys were in regular brick and mortar, you might have even had these in your classroom. What do you think of? What insect is typical when we're talking about butterflies, and they go from our larva to our chrysalis to our adult form, our butterfly. Okay, and that's change that's taking place over a period of time. Metamorphic rocks are rocks that are changed from heat and pressure over a long period of time. That could be an igneous rock being changed, a metamorphic rock being changed, or a sedimentary rock being changed. I'm going to order some Lucy to do with raise with Maggie in the spring, I think. I think she would really like that, and she's starting to get really into science, which is fun. All right, and here, if it wasn't 9 o'clock in the morning, you would see me on a webcam snacking on a Snickers. How does Snickers relate to rock? Specifically, looking at this picture, what I want you to do with your whiteboard tools is I want you to take your whiteboard tool and I want you to draw a line where all the layers separate. Go ahead and do that now. You guys can use different colors and we can have many different lines up there. Use your whiteboard tool and draw a line where the layers are differentiated from the next layer. I know, see, last year I did this lab right after we did it in November, so I had tons of Halloween candy still stashed in my pantry, and I just pulled out a Snickers and did it on the webcam. Okay, so we have lots of lines, and those lines are dividing our Snickers into what? Go ahead down here and write the L word. Not love, but what are those lines dividing our Snickers into? Layers, very good, and you can put that on the whiteboard if you would like. So what type of rock can a Snickers bar model? And now this is the perfect reason that all of your parents and learning coaches should go out and buy you a Snickers bar to eat today. For science. What type of rock do you think this models? We talked about 3, metamorphic, igneous, or sedimentary. Right, and if you want to go ahead and type that on the whiteboard, Becca, Lucy, Alicia, very good. More than one person can type it up there. Sedimentary. So today you can say, Mom, I need you to go to the grocery store and I need you to get me a Snickers bar because we learned about that in science today and it's a model of a sedimentary rock. And specifically, obviously there's not caramel and crunchy peanuts and nougat in our rocks in the earth, but what is it modeling? What do we see in sedimentary rocks that we see in Snickers bars? Nougat? I just think that's a weird word. Or nugget? It's nougat, I'm pretty sure. Okay, Keelan, don't have no allergic reactions because of science, so you just stay away from the Snickers bar. What do we see? There's stratified. We see this word stratified, and when we see the word stratified, we should think of these L words. Layers. Layers. When something is stratified, it means that it has layers. What are some other things in real life examples of things that have layers? I'm trying to think, like plywood. There's all kinds of things we see in our everyday life that are stratified. And stratified simply means that it's separated, it can be separated into layers. Lasagna, that's a great example, Becca. I kind of want some lasagna. That's a fantastic example. I'm going to write that down for next year. Maybe I'll change this picture. A sandwich, very good, okay? So this is another word you probably may have already known, but if not, you can whip this one out today. Mom, I need a Snickers because it's stratified and satisfied. Stratified, layers, and that's what sedimentary rocks have. All right? Round of applause. You guys are doing awesome. And now, I know you cannot, and we talked about this before after. We're going to skip that. We're going to do one quick breakout room activity, and then we're going to do the lab. Minerals, these are 5 characteristics. You need to remember this for your test on Monday. We will be doing the test together because we flew through this unit at a breakneck speed. So make sure you're in session on Monday, but you should know for things like TSSA testing and life knowledge, minerals, 5 characteristics they must meet: inorganic, solid, regular chemical composition, crystalline structure, occur naturally. Okay? In your breakout rooms, you are going to be answering this question. Is a pearl a mineral? Is a pearl a mineral? And you're going to get this slide with the picture and the question, and you're going to get this slide. In your breakout rooms, you are going to circle the characteristics that it meets. If it meets all 5, you'll circle all 5. If you're not 100% sure, you can use Google or whatever other search engine you want in your breakout room to take a look to see if you need to answer a few questions, like does it have a crystalline structure, or does it have organic matter in it? Okay? So in your breakout rooms, you're going to be answering this question, is a pearl a mineral? And you're going to be doing that by circling the characteristics that a pearl meets on this whiteboard. Any questions on what you're doing in your breakout rooms while you guys are doing that, I'm going to be getting my goggles and apron on. If you know what you're doing in your breakout rooms, put up a green check. And you can Google, because you may not know enough about a pearl to answer all the questions, and when you don't know enough, it's always okay to do research and look it up unless it's a test or an essay that you're supposed to be doing on your own. Okay, Caitlin, Keelan, Ron, do you know what you're doing in your breakout rooms? Danny, Dad, let's get those green checks up so we can get them moving. All right, here you guys go. Strap on your seatbelts. And we're going to put you guys in breakout rooms. There are how many of you here? Perfect. Put you guys in groups of 3. Away you go. Once you have your slides, put up a green check. Do you have your slides? Oh, really? Green check. Alright, room 1 is paying attention and listening. Numbers into actual numbers. And luckily I brought you guys back just in time to see that Alicia is quoting her knowledge from SpongeBob, so that is fantastic. Okay, so in your breakout rooms, hopefully you got this finished. If not, we're going to go over it now. I want you all have your whiteboard tools. I want you to circle so we can still see the characteristics that you circled in your whiteboard room on this board. So for example, all of you should have circled solid. Okay, go ahead and circle the other ones that you circled in your whiteboard room, on your whiteboard in your breakout room. More than one person can do this. Go ahead and do that now. I have my goggles and my apron on. I'm ready to start the lab, and let me tell you, this is a new set of goggles, and it smells very chemically. Okay, and looks like everybody did an awesome job. Did you guys go to Wikipedia like I did this morning? I then also referenced it to other sites too, because Wikipedia can change depending on who types the information up there. Is that what it is? Is it the apron? That's, oh my gosh, it is really horrendous. Okay, so yes, you are correct. Obviously we know a pearl is a solid. It does occur naturally. It also can be made in a lab. Pearls also can be made in a lab. Pearls do not have a definite crystalline structure. What shape are pearls? What shape are pearls? Yeah, it's really strong. I may have to do that once I show you guys my get up on the... It's a circle, it's round, so it's not a definite crystalline structure. The chemical composition can depend on what irritant the clam has inside of its, or oyster has inside of its, the chemical composition of the particle or the irritant that the oyster starting to make the pearl round, and it is not inorganic. The substance that the oyster puts around the pearl is nacre. I gotta look out how to pronounce that. But anyway, this is organic. This has organic substances in it. So right there, that negates it meeting this characteristic of being inorganic. So awesome job, great quick research in your folks' room. High fives to everybody. Give yourselves a pat on the back. And now we're going to go ahead and get started on the lab. Okay, today we're going to be identifying rocks and minerals with your kit. You are going to be looking at color. You are going to be looking at streak, luster, and hardness. You need, and here we go, here comes the webcam. And I am going to move my teeth. Where did they go? Okay, can everybody see me? You want to adjust your webcam to fine color. Okay, you want to adjust your webcam to fine color. Alright, I'm going to move, you should never have drinks or food in the lab, so I'm going to move my tea out of the way. If you can see me, put up a green check. Okay, Joseph, you're going to go over to where the little video is popped up, and you're going to click on, yours might say coarse grays, you're going to click on that black triangle that's pointing down, and you're going to select fine color. You've got to click on the little arrow, and then it will give you the choices: coarse grays, coarse color, medium grays, medium color, fine grays, fine color. You want fine color. Okay, fantastic. So Joe, Penelope, Caitlin, if you can see me, put up a green check. Leon, if you can see me, put up a green check. You can put on your special gloves. We're not working with, in brick and mortar, I always use hydrochloric acid for this lab, but we're not, I don't think they gave you guys any of that. So there's nothing in here that's really going to be caustic to your hands. Yeah, sulfur, I mean, it's kind of stinky, but you should be okay. Alright, first thing, you're going to need a hand lens. Your hand lens comes in this little red box, and it's labeled hand lens. Okay, and it looks like this. I'm going to open mine up. Go all the way, Lucy. Do it. Okay, I'm going to open mine up. Okay, I'm going to go ahead and just Here's the box. There we go. My goggles are digging into my forehead. So here is my hand lens. It looks like this. Okay? And that allows, what does the hand lens do? Did I open the wrong? Well, this one was taped too. I took the one with a smaller piece of tape, but maybe that would have worked better, Becca. It magnifies, exactly. So here's our hand lens. Okay, next, iron filings. They come in this little container. Let me turn it around. And they're labeled iron filings. Alright, these make a mess, so be careful when you open these. These make a mess, so be careful when you open these. If you didn't double check, it should be in there. If not, it's okay because you can just get data from me, okay? So we have our iron filing. Street plate looks like this. It's called a tile, and that's all it is. You might use these to tile your bathroom, okay? So it's a white tile, comes in a bag, and it looks like this. Alright, if you do not have this, you can use a white piece of paper or a 3x5 note card. Okay? So if you don't have this, you can use a white paper or a 3x5 note card. So it's not the end of the world if you don't have your street plate. This is a pretty important test. So you want to make sure you have something like a note card or paper or this. Yes, the iron filings are in a plastic. Okay, here, microscope slides. You only need one of these. Now these are glass, so you do want to be careful because glass cuts and that hurts. It's a 12-pack, you only need one. You're going to be using this to test hardness. I'll open that later. And you also need this guy. Your Earth Science Reference Guide. If you do not have this, do not fret. It is not the end of the world. This is also online in your course on the left-hand side. Under Course Home, you click on it and this whole book is online. Specifically, you're going to be looking at pages 28. Oh, look at that. I opened to 27. 28 to 39. Okay? Also, oh no. Hey Jess, do you have a nail? I meant to take one out of your door, but I didn't want to do that without permission. Do you have a nail? Nail? Yeah, like a hammer? Yeah. Can you get me one? You need a penny. Okay, hopefully you have one of these hanging around. Check your couch cushions. Maggie was like in tears, but that's my money. This morning I was like, I'm going to give it back. I miss the days when a penny meant a lot. A magnet. You may have seen this creature last week. Maggie painted art while we were doing class. There's a magnet on the end of this, so I'm going to once again feature her beautiful lion. Get one off your fridge. And you need vinegar. Any type of vinegar will do. I am using white vinegar. Last year I used apple vinegar. It was fine. Okay? If you want to get really fancy and you're all gourmet in your house, you can use balsamic. But the clear ones work better. And generally this is what people have. And you also need paper towels because this can be messy. And finally, the most important thing, which looking at this is kind of funny, I don't see it on the materials needed list. You need your, no, I don't need a hammer. You need your rock kit. Okay, it comes in a white box. It should be at the bottom of your materials box. Okay? If you don't have all these things together now, don't worry, just sit tight, observe what we're doing, and then you can do this on your own later. Okay? I just want to get us started and get most of the information filled out. And when you open up your rock and mineral kit, I'm burning it really bad. It looks like this. All your rocks and minerals are in there. I used to love to collect rocks and minerals when I was younger. And some nails. I have nails in a bag. These didn't come in your K-12 kit, so just find one around your house. No, you can have my toast. I just used a little penny nail. Alright, so those are your materials. Okay? Any questions on what your materials look like or where you find them? As a reminder, and you can move me, like you can move my head around. You can move it down to the right-hand corner so you can see your whiteboard screen and your
and me at the same time, and my sister walking around in the background making sense. I'm sorry. All right, these are things that K-12 sent you. I'm circling the ones that you supplied. Any questions on materials? All right, give me a smiley face if you're ready to get started. Here's your rock and mineral kit. I'll get it out later. I knew I meant to get this last night. All right, lab report. Lab report looks like this. Once again, you should have your lab report open on your computer because we're going to start typing on it ASAP. It looks like this. It lists your materials, it lists your procedure. Actually, these are your directions. Let me pull up the lab report. The lab report's real simple. Bye, Becca. Relax with your family today and let me know if you need anything, okay? You can make this up over the weekend. Okay, so this is what your lab report looks like. We're going to start with number 1. Number 1, we're going to complete the following data table as we conduct the lab. So what you're going to see me do here is I'm going to go back and forth between my directions. Okay? The directions go in the same order that the lab report does. So you just follow the directions step by step by step by step, and you won't miss anything. All right? So number 1 says complete the data table as you conduct the lab, and I highlighted the things that you really need to pay attention to. All right, let me bring up the directions. Here we go. So I'm going to go to the top. We went over what our objectives are. Remember, one more time, safety, if you're doing this at home, microscope slide, glass, breakable, streak plate, tile, it can break and be sharp. Nail, obviously nails are sharp. Be careful. Do not want any hospital visits. We're going to be looking at color, streak, luster, hardness, and special properties. We are going to be using these 5 samples. Now, there's an answer key in your kit. I don't know why they do this. It drives us absolutely batty. Put this away while you're doing this lab, and then later you can check up with this. Okay? All right, so I'm going to go ahead and pull out number 7. The one year, this was tons of fun because while I was doing the intro, this was when Maggie was little, she was taking the little stickers off of all the rocks and I didn't realize it. So when it came time for me to pull out some of them, I couldn't find them and it was very stressful. This is number 7. If you can see number 7, put up a green check. Can you guys still see the webcam? Okay, number 7, mine's little. It has a 7 on it. You're going to get out number 7. The first thing we're going to do is we're going to look at the mineral sample in good lighting with our naked eye. What does our naked eye mean? Does that mean our eye doesn't have any clothes on? When you're looking at something with your naked eye, what are you not using? Any type of what? An unaided eye. Now, if you wear glasses, obviously you're going to keep your glasses on. However you would naturally look at things, okay? So the first thing you're going to do, here's a rock. Okay, I'm going to look at it. It's kind of white, kind of shiny. Looks like it's made up of different fragments. And I'm going to record the color. So what color would we say number 7 is? Take a quick look at yours, if you have it, or mine on the webcam. Type it in the chat box. Whitish. Yep. And that's all we're going to do. We're going to go to our lab report, and we're going to type whitish. That's fine. Or you can just put white. Okay? I'm going to make my answers a different color. That way you guys recognize what you're supposed to be typing. All right, so go ahead, type white on your lab report. Once you have that typed, put up a green check. Yes, the 8th. So I gave my plug for K-12. It's coming off. It smells like tires and gasoline. That can't be good, real. Sorry, K-12. I technically really don't need my goggles on, but I'm just going to leave them on because it's fun. Anytime you're using anything like acids and stuff like that, I mean, vinegar could get in your eye, but it's not as serious as something like hydrochloric acid. All right, so Alicia, Austin, Caitlin, Leon, still waiting for your green check, and Ron. All you're doing is typing white in and then putting up a green check. So still waiting for Alicia, Doug, Caitlin, and that's it. So we want to try to get as far as you can, folks. So I need you to get this typed in and green check up so we can move on. Oh, there we go. Caitlin and Alicia, still waiting for you ladies. You guys in here? Anybody on a potty break? If you were, you couldn't tell me? Okay. All right, Caitlin, just leave that green check up. Alicia, make sure you get your white typed in. All right, so we did the first part. We're going to go back to our directions. And it tells you where to put this. Number 1 in your lab report. You're going to refer back to this when you answer number 3. We're going to place the streak plate. Okay, I have my streak plate on my work surface and hold it with one hand. All right, so I'm going to show you how I'm going to do this. So I'm going to put it down on my work surface. I'm going to hold it with one hand. I'm going to take my sample and I'm going to drag it across my plate. Okay, now this is going to be really hard to see. If you do this at home, it'll be easier to see. And I don't think you guys can even see that. But that tells you what color is the streak. What color is the streak? I can only see it because my eyes are better quality than the webcam. Yes, apparently white. Very good. So you're going to go back and you're going to record the color of the streak into the data table. All right, so go ahead and do that now. We're going to put white. All right, type that in. And we're going to move on to luster. Once you have white typed in, put up a green check. This should only take a couple seconds. There you go, Doug, right on it. Kristen, good job. Get white typed in on your lab report and get up your green check. So wait, there we go. Didn't even get to say it. Leon, Keelan, Caitlin, and Danny, and Alicia. Green check. Okay, now we're going back to our directions. We recorded it in our data table. We're going to look at luster. Okay, so I'm going to take my rock or mineral sample, and I'm going to hold it up towards the light in my kitchen, or my sister's kitchen. All right, so this is me holding it up towards the light, and it tells me, notice how, I got to move my head out of the way. Notice how the mineral reflects the light. All right, and it is reflecting the light. It's kind of shiny. So it says, remember, some minerals may be dirty, so try to determine how a clean portion of the mineral looks under the light. Use terms such as metallic, non-metallic, glassy, vitreous, soapy to describe the luster of the mineral. Keep in mind that this is subjective. That means it's based on opinion. I think it's shiny. So I'm going to go ahead and put shiny for mine. If you look at yours and you want to describe it differently, go for it. Okay, it definitely reflects light. Go ahead and fill yours in and put up a green check when you're done. Okay, and keep in mind that this is objective or subjective, so this is not going to be the determining characteristic that you use to identify what your rock or mineral is. It's taken into consideration, but it's not weighed most heavily upon. You can put that, shiny, sparkly, Lucy, that's fine. Next, hardness. We're still waiting for a few people. I'll give you guys a second. Lucy, Leon, Doug, and Alicia. Alicia, I'm not sure where you're at. Alicia, are you in here? If so, give me a smiley face. Alicia, are you in here? Alright. When she comes back in, I'll have her let me know. Okay, so it looks like everybody does. Go ahead and finish getting this filled in. Now we're going to look at hardness. This one, remember, is a range. We can't give an exact number. We're giving a range. We're going to gather the following materials. Fingernails. So I'm just going to use my beautiful, unpolished, probably needs to be filed fingernail. A human fingernail has a hardness around 2.5. So if my fingernail can scratch lucky number 7 sample, does that mean the hardness is more than or less than, greater than or less than 2.5? If my fingernail can scratch, right, less than, okay? Penny has a hardness, where'd my penny go? Where'd my money go? Penny has a hardness of 3.5, around 3.5. A nail, where'd my nail go? Here we go. A nail, this is a nail that you would use a hammer with, 4.5, approximately. Our glass microscopes, carefully open up my glass microscope. Okay, so right now I'm opening them. Remember, these are glass. Please be careful. Glass microscope, a hardness of approximately 5.5. And our streak plate, if our streak plate can scratch our sample, does that mean the hardness of our sample is less than 6.5 or greater than 6.5? Our streak plate has the greatest hardness. If our streak plate can scratch our sample, does that mean it's less than or greater than 3.5? What do you guys think? And Lucy is right once again, it is less than, okay? So we're going to go ahead and we are going to take it. You're going to start with the least hard. I'm actually going to take my goggles off so I can see what I'm doing. Alright, so I'm going to take my fingernail and I'm just going to scratch my fingernail on the sample, and what's happening is my fingernail is getting scratched, but the sample is not. So then I'm going to go next. What came after fingernail? Was it penny? I took the other away. It was giving me a headache. Is penny next? Can you guys give me a smiley face if you remember from your directions, or if you have your directions open on your computer? Yes, okay, thank you, Ron. I'm going to take it, and I'm going to scratch. Nope, my penny's not scratching it, so I'm going to go to the next thing. And the next thing was, I can't remember. What came after penny? Anybody remember? Let's take a quick peek. Regular nail. A regular nail. Okay, so I'm going to take my regular nail, and I'm going to scratch. I'm going to set this down to do this. I don't know if you guys can see that. Let me adjust real fast here. Let me move. 1 second. I gotta move myself up so I can see what you guys can see. Okay, there we go. So I'm gonna take my sample and my nail and scratch it. And my nail's not scratching it. So as of now, I can say, if I had to stop here, what information could I give about this hardness? It's greater than what? My fingernail didn't scratch it, my penny didn't scratch it, and my nail didn't scratch it. So what's my hardness greater than? It's chipping yours. Okay, well what you want to do is take an area where it's not as fractured and scratch it. There. Mine's not doing anything. Let me double check something here. Give me a second. Go ahead, if you're doing yours at home, go ahead and go on to the next one, the glass slide. Be very, very careful. If you're doing this at home, go ahead and put your hand up, just so I know who's participating along at home. Okay, just leave your hands up for 1 second. I want to look at something. Okay, yeah. If it's chipping it, that's a little bit different. A scratch, you're going to look at an area that's, not, like I said, not really fractured. My nail's not scratching it. I'm next going to move on to my plate, and I'm going to do this oh so carefully because this is glass. And mine's not scratching, but my glass plate is. So you guys can't see this, but the corner of my glass plate actually scratched a little piece off of the glass plate, but the sample didn't scratch. So we know that our sample, the glass plate, didn't scratch it. We know that the sample is greater than or less than 5.5, is that what it was? I'm looking. There you go. It's greater than 5.5, exactly. And then finally, what we're going to do is we're going to go to our streak plate, and I'm going to find a non-fractured area. And now, and I don't know if you guys can see this, how well you can see this, but I'm going to put it up here. You can't, it's so blurry. But if you're doing this at home, you'll see that the streak plate actually did scratch the sample. It did scratch the sample. So we know that our hardness is what? We know that our hardness is what? Greater than or less than 6.5. If the streak plate scratched the sample, and let me go ahead and application share. Very good. So that's what we're going to do. On our lab report, I'm going to bring it back up here for you folks. All right. Can you guys see the lab report? Just so give me a smiley face. This first one always takes the longest. All right. We're going to put up here that 6.5 is greater than. Our hardness is less than 6.5. Our glass plate didn't scratch it, but our streak plate did. And we know our hardness of our streak plate is approximately 6.5. Special properties, we're going to look for special properties. Okay, so for special properties, you can smell it. For special properties, you can take your vinegar. So let's start. Let me pull my webcam up so I can see what you guys are seeing. For special properties, you can take your iron filings. Okay, now, if I take my iron filings and I sprinkle it on my sample, alright, and then I turn my sample upside down, if my sample was magnetic, what would happen to my iron filings? Would they fall or would they stay? Alright, if I did this, if I put my sample in, what would I see if my sample was magnetic, which is a special property? If this sample 7 was magnetic, what would the iron filings be doing? I think I might have to move my chat down. You guys can go ahead and share your thoughts in the chat box. If this was magnetic and I put my sample near it, the iron filings would do what? They would stick to it. So my iron filings aren't sticking to it, so that tells me that it's not magnetic. It's not sticking to my magnet, so it doesn't have iron in it. It doesn't stick to my magnet. It's not magnetic, my iron filings don't stick to it. Smell it. Okay, it doesn't really have any distinct odor. There will be one that has a distinct odor. Something else you can do is take your vinegar and your pipette. Where'd my pipette go? Alright, well, we'll just pour some. You can take your vinegar. Sorry, K-12. I just got vinegar on my laptop. Okay, and if you put a little bit of vinegar on your sample, listen, look, does it bubble? Does it fizz? Is there a chemical reaction going on? No. So what you're going to put, for some there will be, but for this sample, sample number 7, there's not. So what you're going to put, I'm just going to double check to make sure I didn't miss any. Yep, that's great. That's not what I wanted to do. That's not what I wanted to do. You can put none for special properties, and then using your key in your book, you can look through pages 28 through 39. And that's what I'm doing. I'm getting my book out. Okay, and you can look through, and what you should identify this as is number 7, quartz. And really, they don't give you a dichotomous key, which they should, and it drives me crazy. So the main reason you do this is just look at here. Number 7 is quartz. and then you fill it in. It's really silly. What they should have is a key that says, does it do this? No, go here. Does it do this? No, go here. So you can look in your book, but you also ultimately are just going to look at your key and see what it is. Okay? The one thing that's good about this lab is this then allows you to learn the properties that these rocks and minerals have, but it doesn't really let you key it out. So that's the one thing I really don't like about this lab. And you're just going to put quartz in. Okay? All right, what we're going to do now is we're going to go ahead and do the next one together. We're going to move faster through sample 20. So go ahead and get the rest of sample 7 filled in. Once you have it filled in, put your green check up. Once you have it filled in, put your green check up. I don't know where Alicia went. I'm going to wipe my, oh, I have paper towels here. See? If you would need them. Okay. All right, so now I'm going to get out sample 20. I'm not going to look at my answer key until after I'm done. I'm going to get out sample 20. I'm going to put friendly sample number 7 back, goodbye number 7. Sample 20 is pretty cool looking. Get it out. It looks like this. Shiny. Has a couple different colors in it. If you have your rock kit, even if you're not doing the lab, at least take a look at the samples so you can identify or recognize the colors. Okay? So what color is your sample 20 if you're following along at home? Also, if your glass, mine broke the glass. It scratched the glass. Okay, mine is red and black. Caitlin, yours is blue, number 20? Okay, put it in there. That's fine. Remember, color is the same sample. Like my sample 20 is red and black. Caitlin's is blue. That's why we don't go by color as our only identifying property. We also specifically rely on streak because Caitlin's streak and my streak should be the same color, even though the color, the visual color of our sample is different. So I'm going to put red and black. You put whatever color yours is. If you don't have yours at home, and you're just going to put in what I have. Red and black. Okay. Now, once you have color, we're going to do streak. You're going to get your streak plate. You're going to get your streak plate. You're going to get your sample. You're going to do your streak plate. Go ahead and do that. If yours is green and black, Danny, that's fine. Put it down. That's perfect. I get my streak plate. I take my sample, and I drag my sample across my streak plate. Side. Okay, and I'm looking at the color of the dust that's left behind. You can't see it real well, but go ahead and do this at home. And I am going to do this. I want to go into the PowerPoint. So go ahead and drag yours across the streak plate. Once you have yours dragged across the streak plate, go ahead and put what color the streak is. Oh no. I can barely see mine too. Can anybody else see their streak? I don't really see mine at all. It doesn't even look white like the last one did. Anybody see their streak? Okay, so that's what you're going to put. So for sample 20, we did this one. We already did sample 7, so you should already have this filled in. For sample 20, you should have your color. I'm going to put red and black. My streak, I didn't have a streak, and that's all you put. You're not always going to have a streak, and that tells us as much information as a streak with color would. Okay, so you're just going to put no streak. All right. Luster, you're going to take your sample. you're going to put it up to the light, and this is really smooth, shiny. I think mine almost looks glassy. Would anybody else use the word glassy to describe their luster? I think mine almost looks glassy when I put it up. Okay, honesty agrees, so that's what we're going to do. If you would describe it a little bit differently, do that on your lab report. Okay, shiny, glassy. And then we're going to take our sample. We're going to start with our softest or least hard testing tool, which is our fingernail. We're going to scratch. My fingernail doesn't, it just slips right over it. So we know we got to go up. Our hardness is greater than 2.5. Next we use, it's our penny, I think. And my penny just slides right over it. Now my penny might break off, like there's a few little loose pieces up here. It breaks those little pieces off, but that's not the penny scratching it. That's just the force of my hand pushing on it. But when I slide my penny over a slick area with no little pieces fracturing off, nothing. Okay, so our hardness is, we know our hardness is at least greater than 3.5. Next, that brings me to my, I think it's my nail. And I'm going to put this down so I don't cut myself. And nail is just not even making a mark. Not even making a mark. It's still where I'm scratching the nail, it's still shiny and glassy. Next is my glass plate. I'm going to be very, very careful. You want to do this very, very carefully. And I'm going to look. No scratch, still glassy. And so I'm going to go to my streak plate. And I don't know if you can hear me scratching. And I don't have a mark. And let me just double check the answer key. Because sometimes what can happen with these, okay, it's saying that my glass, did anybody's glass slide scratch it? Mine didn't. Let's try that again. The answer key is saying, and this is why I always refer to the answer key in this one. Maybe I wasn't pressing hard enough because I'm scared I'm going to cut myself. No, like I said, juicy little lines. There's no way you guys are going to see them. But if you're doing it at home, you may. Okay, that's all we need, Lucy, is a very little bit. So we know our glass slide is 5.5. We know that our other tester, hardness tester, which was our nail, is 4.5. The nail didn't scratch it. So we're going to say our hardness is between 4.5 and 5.5. Remember, we always give a range, less than, greater than, or between. So that's what I'm going to put here. And I'm going to make this smaller. And actually, let's do 4.5 to 5.5. So I'm going to change that to 5. Because our nail didn't scratch it even a little bit, but our glass slide did, so we know that it's greater than 4.5, but less than 5.5. So I just put 5.5 to 5.5. Okay, we give a range or less than and greater than. Any questions on hardness? That's fine, Lucy. I know I'm having a hard time seeing and I don't even wear glasses. Okay, special properties. I'm going to give it a big old sniff. I'm probably not going to want to taste stuff in my science lab. That's a bad idea. I can see if it's magnetic. Does it stick to my line magnet? Nope. So it doesn't have iron in it. I take my iron filings. Do my iron filings stick to it? Nope. So it's not magnetic. Take my vinegar. There my pipette is. Ah, here it is. This is much better. You want to use your pipette for this. Take my vinegar. Okay. Put a dab on it. Does anything happen? I'll try to get an area that's a little roughed up. No, no bubbles, no fizzing. If the vinegar would fizz or bubble, that would indicate a chemical reaction, and that would be a special property. So there aren't any special properties, so I'm just going to leave that. I'm just going to put none. The suction thing's in the kit. It took me forever to find mine, like 20 minutes this morning. I had to tear everything out twice. All right, mineral name, you can look in your book. For some of them, it does help you key it out. But all you're going to do for this one is we're just going to look at here to save time. And it's obsidian. Now, in regular school, I had a key that the kids followed. I don't know why K-12 doesn't do that. Write a letter to K-12. Tell them that you want to do that. Obsidian. Number 20, so I'm just going to type that down here. Obsidian. Okay, so you can see I can only grade this based on the text. The mineral name, anybody can write it without even doing it. Okay, we're going to fly through the next one. I forgot my I in obsidian. There's that little guy over right there. All right, sample 25. I'm going to find sample 25. Looks like this. Go ahead and get yours out. What color is sample 25? Let me put this up so you have a little better light. What color is sample 25? Sample 25 is already filled in. You are correct. I don't know why I don't have it. Okay, so sample 25, we should have red. It's streak. Go ahead and streak that now. If you're working on this at home, do your streak now to see if your streak matches up with what it says. Ooh, this is a good one. What color is our streak? You see this on the answer key. It's reddish, okay? I'm just taking a look. This is filled in on yours, so I'm not going to write it up here on the board. Our hardness is between 5 and 6.5, and this is hematite. This is hematite. All right, we're going to move to sample 27 because this is generally an interesting one. Sample 27. What color is sample 27? If you're at home, look at yours. If you're looking at mine, you can sort of see it. Yellow, that's right, Caitlin and Lucy, very good. So I'm going to put that in here, yellow. Okay, I'm going to do my streak or my streak plate. Ooh, this one is soft. Okay, what color is my streak? If you did yours at home, what color is your streak? Same color as the sample in this case, yellow. All right, luster. How would you describe luster of this? Go ahead and hold yours up to the light. Hold yours up to the light. And how would you describe it? When you hold yours up to the light? Mine, the answer key says dull, but mine's actually kind of shiny. And that's why this is so subjective. Anybody else have a shiny sample, or does everybody have a dull sample? I would say sparkly flecks, yes. I like that. Sparkly flecks. That's what mine had. We're going to put that. Hardness. Hardness. I'm going to take my fingernail. I'm going to scratch it. Okay? I actually was able to get mine to scratch with my fingernail. Was anybody else able to? You're probably not. Like it's on my fingernail. I don't know if you can see that. Probably not. There's a powder under my fingernail. If yours is dull, Joe, put dull. Okay, that just reiterates that that color, visual color, should not be relied on because it's subjective. All right, so then we know that our hardness is less than what? If our fingernail can scratch it, our hardness is less than what? Go ahead and type it in the chat box. What's our hardness less than? 6. Let's look back at our directions. That's probably what you guys are like, well, wait. A fingernail. Give me a sec. Let's take another look. Fingernail is 2.5. There you go. Great job, Ron. Good memory. 2.5. So it's less than 2.5. All right, go ahead and fill that in while I'm filling it in on mine. All right. Special properties. This is a fun one. So, When you smell it, what do you notice about our sample number 27? What do you notice about our sample number 27? If you're following along at home, go ahead and take a big old sniff. Black. Okay, black. Yes, it does smell black, but let's try to find something else that would describe it a little bit more. Sulfur, this is sulfur. I mean, you guys can look at the answer key and tell. Sulfur has a very, very distinct odor, and most people describe it smelling like, I just broke my sample into, rotten eggs. Very good, Keelan. Yes, Lucy, rotten eggs. So that's what we're going to put. Smells like rotten eggs. Okay? You can, it's not going to be magnetic, I can tell you that. It's not going to have iron in it. You can take your vinegar. And actually, I don't know if you can see these little specks here, but I have some that crumbled off. I'm going to take my vinegar, here's another chunk that crumbled off because it's not very hard. And put my vinegar on it. There's no fizzing, there's no bubbling, so there's no chemical reaction. You know, it's not magnetic. So really the only and most important special property that allows us to identify sulfur before you even see it. Some people have water that's sulfury. It smells like rotten eggs. Did I just put this in the wrong sample area? I did, didn't I? That's the street cleaner here. Okay, I'm going to shift these, get yours filled in. We're going to do the last one. We are almost done. Down here I'm going to put sulfur. All right, sample number 35. I'm going to get that out while you guys are finishing this up. And you can go through this kit. This is your raw kit. You're not sending this back to Code 12. So what, I don't think they have you guys. Do they have you send these back? I don't think they do. They should. Anyway, you can go through, there are ones in here that will have chemical reactions. So you can go through and see which ones have a chemical reaction by dropping the vinegar on them, scratching them up a little bit and dropping the vinegar. That's pretty cool. Take a look. Some of them are magnetic. Take a look and try to figure out which ones you think are magnetic by seeing if your iron filings stick to them. So you guys can play around with these beyond what we do here in class. Okay? All right, number 35. 35. This is my 35. What color is mine's kind of pinkish. What color is your guys' 35? What color is your? I don't see why they would have you send your rock samples back. Let's put it this way. If you don't send it back, if you don't send your computer back and you leave, that's a big difference. But if you don't send your rock kit back, I don't think they hand these back out because the rocks are always scratched up and broken up. Like pink, yes. So play around with them. Look up some things you can do online with them. And I will look up actually an activity to send out as an extension activity because I feel like we should be doing more with these than looking at the answer key. All right, the sample that actually, does anybody have a light blue sample? Does anybody have a light blue sample? Mine was light pink. The answer key says light blue, so it is possible that you have a light blue. I'm going to take my streak plate. Where's my 35 here? I'm going to take my sample number 35. And I don't have a streak. The streaks you're seeing are the ones that go on this side. Anybody else have a streak? I don't have a streak. Kind of. Okay, if it's whitish, then put that in there. I have no streak, but if it's whitish, put it in there. All right, as a scientist, it's more important to put what you see, not what the answer key says. All right, luster, definitely. This guy is shiny. He's reflecting a lot of light. So I'm going to put, mine's actually kind of glassy. It's a bigger sample, so it's easier to see. So I'm going to put that. Okay. Hardness. I'm going to start with my fingernail. Can you guys see? Let me move this up. I can't see what you're saying right now. I'm trying to move my camera. There we go. All right, can you guys see my sample? I'm going to start with my fingernail. Nope, it's actually just kind of broke my fingernail. So definitely harder than 2.5. Next, I'm going to go to my big money, my penny. There's a little cabinet on the back of it. And didn't scratch it. Didn't scratch it. So I'm going to go to my, what comes after that? My nail. This is actually scratching it. So my nail is scratching it. So we know our hardness is what? Less than what? Lucy put that, shiny patches and dull patches. Whenever you're actually doing real scientific work, you want to put whatever you observe as detailed as possible. Okay? So if my nail scratched it, my penny didn't, but my nail scratched it, that tells us that our hardness is what? Less than. Let's take a look. You guys might be waiting for this. Anybody remember? Our nail is 5.5. Our nail is 4.5. So my nail scratched it, but my penny did not. So our range is what for hardness? My penny's 3.5. It didn't scratch it, but my nail did. We know it's greater than 3.5, but less than what? You can put between 4 and 4.5. Okay, because like I said, our nail scratched it. Not my fingernail, but the regular nail, this guy. So we know it's between 4 and 4. It's not, it's going to be less than 4.5. So I just put between 4 and 4.5. All right, any special properties about this? Take a big sniff. Do not eat it. I still smell it. It was sitting in my sulfur, so mine smells like sulfur. Taking my magnet. Does it have iron in it? I don't know. Does it stick to our magnet? Does it stick to the lion magnet? Nope, it's not sticking. Taking my iron filings. Does it have magnetic properties? Nope, my iron filings aren't sticking. Take my vinegar. I have my rock sample or mineral. Put my vinegar on it. Nope, nothing. No fizzing, no bubbling. So, no, none. I'm going to leave that blank, and then when I look at my key, I see that number 35 is fluoride. Okay? So we have the chart filled in. We're going to go ahead and quickly answer the last couple questions, and then I'm going to let you guys loose. Actually, rose quartz. They changed it. That's why it's different on the answer key. I wonder if the other teachers realize that. Rose quartz. Okay, and that's why it's pinkish. So we have our whole chart filled in. Go ahead and finish filling in the chart. Once you have your chart filled in, put up a green check. Like I said, I encourage you to play around with this rock kit. Scratch them up, put vinegar on them, see if anything has a chemical reaction. I'm looking now to see which one. I know there's at least one in here that's going to fizz and bubble. All right, Alicia, you're back. Fantastic, my dear. Go ahead and get your lab reports filled in. So Leon and Ron, once you guys have this filled in, put up a green check. All right, Alicia, you're going to have to go back through at the end of class because I want to keep moving. Here we go, lab report. Oh, okay. We're going to now move into the next part. Give me 1 second. We're going to move on to number 2. We're going to move into number 2. Take a look at that on your lab report. We're not going to get all of these answered, and that's okay. I'm just going to grade what you turn in. Tools. All right, we're going to look at number 2. Can you guys see number 2 on the lab report? On my screen, if so, give me a smiley face. If your screens are catching up. Okay. All right, so why is it important to examine both color and streak? Is color reliable? We saw some people for, I forget which one it was. Was it hematite? We all had different colors. So color can vary, but a mineral's streak is always the same. All right, and we talked about this last week also, so go ahead and get number 2 filled in. Color can vary from rock sample or mineral sample to mineral sample, but a mineral streak is always the same. While you're doing that, I'm going to put my rocks back. I'm missing one. Which one am I missing? Oh, button. We are getting ready to be done, Caitlin. So just hang tight for 2 more minutes. Okay, hopefully you got number 2 up. If you didn't, you can always go back and watch the recording. Luster. Why is luster not a good characteristic to use for the identification of minerals? There's one word that we can put there. It is what? Like maybe my kitchen light's brighter than your kitchen light, or maybe your kitchen light's brighter than my kitchen light, so it reflects light differently. Right, it's subjective. Very good. I'm going to steal Lucy's answer. That's fantastic. It is subjective based on the observer's opinion. Okay? All right, we're going to answer number 4. You're not going to do number 6. You're not going to do number 5 or 6. You can do them on your own, but I'm not going to count them against you if you don't do them. Let's put it that way. Number 4, you've been given a sample of quartz. It has a hardness of 7. How can you use this mineral to determine the hardness of others? If we know our quartz sample has a hardness of 7, what can I do with it? What can I do with it? If my sample has a hardness of 7, how could I determine the hardness or a range of hardness for an unknown sample? Okay, so I want to know maybe at least around what this hardness is. I could take my known sample and do what? What could I do with this? I know this guy has a hardness of 7. Oh, he's scratching this guy, so that means this guy's hardness is at least less than 7. Okay, so you can use that known hardness mineral to scratch another mineral to determine if it's at least less than that mineral's hardness. And I'm just going to copy and paste this. All right, so we're going to stop at number 4. You need to do 1 through 4 for full credit. If you want to do the last 2, let me know in the comment box that you want extra credit, okay? Let's do it that way for 5 and 6. All right, I need 1 through 4 for full credit. If you have those done, you can save and submit that now. And I'm going to go ahead and give you guys your ticket out. It's a really, really easy one because I know you got to get into your next session. The lab is due by tonight, by midnight tonight, by tomorrow morning. I won't be grading until tomorrow afternoon, so if you get it in tomorrow, it'll be fine too. Here is your participation. In participation number 5, you are going to put science rocks. Please tell me I have participation number 5 for you guys. You guys are going to put science rocks. And I don't think I even have the participation in there. So you know what, better yet, don't worry about it. I'll put it in the Dropbox for you. I know, isn't it? Wait till you see your progress report comments. All right, I'm going to do the participation. Don't even worry about it. I'll go ahead and make sure it gets in the grade book because I just realized since I wasn't here yesterday morning, I did not put the participation drop box in. All right? So make sure you get your lab report in. And once you are done, you are free to go. There's 12 of you, and I know exactly who it is because it's the same 12 people that always come. If you have questions or need to see one, let me know. Number 4, yep. Go ahead, Joseph. If you have a 10:30 class, go ahead and get going. What is this? Joseph, I'm bringing it up for you, buddy. Give me 1 second. There's number 4, 3 and 4. Lucy, not at this time. We're going to have to cut some things because of the block scheduling. So that's why I'm saying I'm definitely encouraging you to play around with it. You know, look at your mineral and rock and mineral list, look up some characteristics, see if there's any that fizz, because there is definitely at least one. See if there's any that are magnetic, because we won't have time to do anything else with this, which is kind of a shame. This one has great stratification. Number 23 has great stratification. I know. I prefer the non-block scheduling just because it gives us a little more time to do fun stuff. But the plus side is you guys didn't have to worry about that many classes this semester. So, you know, it works. It's got ups and downs. Any other questions? Bye, Austin. Have a great day. Thank you for being patient, folks, and bearing with my webcam. Bye, Leon. You're welcome, Joe. Have a wonderful day. Bye, Lucy. Ron, Danny, or Alicia, do you need anything? Alicia, when you're in session, sweetie, I need you to make sure that you're here the whole time and paying attention. That was the tomorrow, okay. Alicia, are you in here? Alicia.